can chug. Yeah. Okay, so please be careful. When is 0 okay? At the top. When is 0 not okay? At the bottom. So all you have to do is -2 plus 2, then -2 squared plus 4 times -2. So that's what? 4 minus 8 plus 3. Shh. Well, no, I'll try to do the math. So it's 0 over -1, and it's 0. I didn't get 0 at the bottom, so is it okay that this limit approaches 0?
Yes.
Yes, there's my answer. Oh, don't box. Yeah, you're done. It is okay to have 0 at the top. As long as my bottom doesn't equal 0, it's okay. Remember, 2 places we don't want 0. Top of your test or in your banking account.
Yes.
Or in the bottom of a fraction. Yeah. Any questions on that? Okay, I promise. We're going to get through everything. We're going to do one at a time.
Well, Ms. Vitrano, do you like my explanations?
It made me cry. Okay. So far, so good? Number 2. Okay, number 2. Okay, so if I plug in okay, guys, when you plug this one in, you actually get 0 on the bottom. Okay? Because of this 0, we need to look at factoring. Okay? And tell me if I'm going too fast. Do y'all trust me to factor?
Yes. 1 and 3.
Oh yeah, you can vote factor. I need that x minus 3. And so then this would be x minus 1. Right? The x minus 3's cancel out, so I'm left with the limit x plus, it's 1 over x minus 1. You almost had it. Okay, now we plug it in. So 1 over 3 minus 1. Wait, I dropped a negative. Oh no.
Because it has a
It
negative.
has a negative. Oopsies.
On the top.
I know.
-1/2.
Because I was like, I thought there was a negative there. Yeah, negatives are evil. Okay. Yes, no. Okay. 3 and 4 are going to be very quick. We're going to go in order. I promise you we're going to get to all of the questions. Any questions on that one? Are we good?
Yeah.
did exactly that.
And a lot of it's the algebra. And we're going to get to the calculus issues later.
What was the negative that caveat? Wow. Just
Yeah, they're devils. Okay, number 3. I don't think I've ever seen such wide range of answers. Okay, how many of y'all freaked out because there was not a fraction? Okay, if we need to make it a fraction, if you're dying for a fraction, can I do this?
Yeah.
Yes. What's the degree on top? 4. Do I have a degree on bottom? No, so the degree is definitely bigger on top. So the answer is either does not exist or infinity.
I want both of them, but then I already said
Mr.
Disney.
Vitrano,
Okay.
what if you plugged in infinity? That's what I heard.
Okay, can you hold that thought?
I wrote.
Wait.
Can I start some paper?
Okay, oh, so do you want to just sit here?
Yeah, I'm just gonna paper.
Okay, I got paper. Or pen? Okay. Yes.
What happened if it's flipped the other way? Would it be negative? Yeah, it'll be 0.
Say that one more time.
If the fraction was flipped. I'll take the x.
Then the limit would have been to 0.
Why? Because of the 3.
Because the degree is bigger on the bottom. Guys, another way to look at this problem is my highest degree is x to the 4th, right? It's an even, so both arms are going up. So the limit's about end behavior. So what are the ends going? To infinity. Let's see this way.
I plugged in infinity, Mr. Vitrano. That's how I got
I
my
do.
answer.
I don't know how you plug infinity because infinity is still not a number.
I don't know. I was like, if you plug in infinity, it's gonna be positive. So it's infinity.
It worked. Okay. Number 4. I know exactly what y'all did on this one. Okay, degree on top is a 1, right? Degree on bottom is a 1. The problem is, Erica, did you get your test? Okay, the problem is, okay, pause. You're in 6?
But Mr. Vitrano, so for infinity, if the degree is bigger on top, it doesn't exist.
Doesn't exist or goes to
And
infinity.
if they're the same,
Divide by the leading coefficient.
and if the degree is bigger on the bottom,
0.
okay.
Okay, same, right? So what's the leading coefficient on top? What's the leading coefficient on bottom?
1.
Y'all put 3. Some of y'all put 3. So what happens is I think you just kind of go, oh, it has to be the bigger number, and it became negative 3 over 3, and yeah. That was it. That was the limit portion.
All right, now let's get to the hard stuff, Mr. Vitrano.
Okay, any questions over limits?
No.
Okay. Number 5. Here's, okay, chill.
Oh, my bad.
Okay. Let's just put the paper down. Okay. Is the cube on... Don't know why I put the E. This is not cosecant cubed. Okay?
Today, Rutherford, report to the main
That's what
office,
this
please.
side says.
Today,
Cube is on
Rutherford,
what?
report to the main office, please.
X. Okay? 2 different things. Okay? I want y'all to repeat after me. I will like the chain rule.
I will like to.
You have no choice. We gotta like. It is the chain rule.
Got me done.
Okay, so I'm scared to ask. Derivative of cosecant.
Is negative
Okay,
cosecant,
negative
cotangent,
cosecant,
cotangent.
cotangent. Stop. Okay, y'all got to this point, and I was happy. Some of y'all. I said some of y'all. Okay, but here's the thing. I took the derivative of cosecant. This is cosecant of what? X cubed, right? So when I'm taking the derivative of cosecant, y'all know those little brothers or sisters that annoy us, that are always around?
Yes.
Melissa and
yes.
Wanda? Yes. They have to come with you. Okay? So I've taken the derivative of the outside thing, that inside's got to come along for the ride, times the derivative of the inside thing. So now the derivative of x cubed. 3x squared. Yeah, you could have left it like that. Okay, so so what's happening with the chain rule is you getting the idea that you've got to take the outside function, but whatever's on the inside's got to come along for the ride until you take that derivative. Okay, and you got to remember to pull that. Okay?
Is that it?
That's it. If you wanted to clean it up, the best you could have done is this. Okay? This problem, I think y'all made it 10 times harder than it should have been.
Then why can't you put this in here?
I have no idea. Huh? No, this. I was crossing that part out. Okay, any question? You have a question on it? Oh, okay.
Hey, I knew the whatever it's called, the derivatives of the things.
That's okay. Guess what? Why I'm doing the time test.
It's like a random.
Oh,
I forgot during this test.
okay. Guess what's going to probably be on the retest tomorrow? Well, another trick function. Why? Because how else do I torture y'all? Okay. 6.
Oh, bro, I got number 6 right. Give it.
Okay.
Get it.
Okay. Please. Okay, and then you erase it. Okay. So now my next thing I realized, product rule versus chain rule. When is what? Looking at the original problem here, am I multiplying anything?
No.
No, so I'm not having a product rule. Okay, that's why this is the chain rule. Yeah?
Wouldn't the outside be the,
Okay, huh?
wouldn't the outside for that one be considered?
Because it's all x cubed. Think of your trig. I can't sign. You never write. Ugh. Do you ever see this
No, look at this.
with the x? Because we always have to take, with all trig functions, it's sign of something. So even though it does look like it, but with the trig function, it's bedded inside. So this is not really multiplication. Does that make sense? Just rip it. Go for it. Okay. Where here, am I multiplying things? Yes, I have 2 different things together with multiplication. So this is the product rule. Okay? I'll get to that part in a second. Okay, so product rule is the derivative of the first. So the derivative of this is 8x cubed times the second. Okay, and let's do this. So the derivative of the first times the second, right? Okay, so I took the derivative of the first thing times the second thing. Plus the derivative of the second. We have a lot going on here. We have an e, and in that exponent we have some exponent raised to yet another exponent, right?
Right.
Chain rule. Okay, so the derivative of e is e. That did not sound convincing, but I love you. Okay, so the derivative of the outside is the e times the derivative of the inside. What is the inside?
20x to the power.
Well, yeah, I'm at the 4x to the 5th, and the derivative of that would be
20x to
20x to the 4th. So all of this right here is the derivative of the second times the first 2x to the 4th plus 5. Stop erasing your answers, okay?
And then I put 2 or 5.
By doing our math, the purpose of practicing math is that you're training yourself to see these problems and how to react to them, and for me to torture you. You could. Remember, I told you you didn't have to simplify.
How would you say?
You could factor out e to the 4x to the 5th.
Right.
So if I factor that out, e to the 4x to the 5th, this leaves me with 8x cubed. That leaves me with a 20x to the 4th. I would multiply that out and then factor again. Yeah, exactly. I I was happy with this line. Okay, I would have been happy with that line.
I would have, yeah.
Okay, but you see, there's no quick movement through this. It is stopping and analyzing at each section. Yeah? Any questions on that one?
No.
Okay, number 5.
Ooh.
Y'all had good times.
I remember something. 7.
Okay, number 7. Whatever's next.
Where we all feel hungry.
Oh,
Can you hold it?
okay. How many of y'all read the instructions and flipped out? Yeah.
No, I didn't.
You're like, oh my God, in terms of x and y, and is there dx, dy? Stop. You should have just stopped at implicit differentiation. Which hopefully makes sense because there's a y smack dab in the middle of all this. So this is going to be implicit. Y'all started off the problem wrong. You hate this side. Chain rule. I know exactly at this point. I think the next test y'all are going to get is just all chain rule. Yes, I'm going to like exercise your chain rule demons. Okay, so here we go. Derivative of 2x cubed is 6x squared minus derivative of 5y to the third is 15y squared dy dx. Other way around. Okay. A lot of y'all got this far. And then I cried to the other side. Chain rule. Okay. Chain rule because, not chain rule, I'm sorry, stop. Product rule. Why is this one the product rule? We're multiplying x cubed and y squared. 2 is going to come along for the ride. So, derivative of x cubed. Okay, so well, I'm gonna go step by step on this one. So this will be 3x squared times the second, right? And if you want, I could do it. Maybe this will be better. I'll put the 2 on the outside. Plus the derivative of the second, 2y dy dx times the first.
Wait, so why is the 2?
It's a constant. It's just going to come along. I'm going to multiply it in there in a second. I'm going to touch.
So dy dx goes only where there's a y?
Yeah.
Correct. Every time I take a derivative of y, I got to do dy dx. To say I'm taking the derivative with respect to x. Like if I went to go talk to Mr. Taylor on your behalf, I'm not going to go, hi, I'm Christian. It's like, I'm out here on behalf of Christian.
Oh, right.
I'm doing this for. So I'm taking the derivative of y, but I'm doing it for x.
Okay, I got you.
Okay? I'm going to clean up the other side. Again, I took a little bit slower on that side. So I get 6x squared minus 15y squared dy dx to 6x squared y squared plus 4 plus u x cubed y dy dx. Okay. Yes.
In our test, do you want us to box our answers?
Do not box your answers. Okay. Because
Do the negative 3 over 1.
yeah, Erica, I'm not picking on you, I promise. Because Wanda,
Pay attention. Should I explain? I know why. I just
Okay.
wanted.
okay. No. I don't think I said this in 5th period.
You did.
Do not box your
I did
answers.
6. I did 6.
I did in 6th,
She didn't 6.
You didn't tell us.
but in 5th, right.
Yeah.
You did?
No,
Okay.
Can we just
I'm having 5. Yeah. Okay. Here's the thing. Poor Erica had the right answer, put -3, but when she boxed her answer, she put 3. if this was an FRQ, she doesn't get the points because she's saying, I only want you to look here. If she wouldn't have done that on the FRQ, she gets her points because they realize she knows that they just forgot. She didn't tell them, I need you to look here. Okay, so don't box answers. Yeah.
Box the whole thing.
Just don't box. Okay.
Hey, Mr.
Win it, don't.
How'd you feel about I've been erasing it. Like, look.
I'll slap you later.
He just did.
I just crossed it out.
I'll slap you later. Okay, good times, good times. No. Okay, now this is the point we separate our dy dx from the non-dy dx's. I made the decision to move 6x squared, y squared over here. Okay, and then move the 15y squared over there. Okay. Do I need to show my minus sign or can I do that?
Repeat. Just add 15y squared.
Okay, so here we go. I'll put my line in. So I'm adding this over.
And then subtract 6x squared y squared.
So I get 6x squared minus 6x squared y squared equals
15.
4x cubed y dy dx plus 15 y squared.
dy dx. Factor out the dy and dx.
Okay, yo, slow down, homegirl. Okay. The reason why we have to do this is we got to be able to factor out dy dx. Okay. So far, so good?
Yeah.
This was the one question that I put the most weight on. Okay, this was the 10-point question because I felt there were so many steps on this one. Yes. I did it because it matched your jersey. Okay, there you go. Now, can I simplify this side or factor something out? Yes. Why? Please don't. So I'm going to leave this side as is. This is the side where I want to factor. What do they have in common? And keep it very simple. The dy dx. Okay. So I'm left with 4x cubed y plus 15 y squared dy dx. Okay. So far, so good?
Yeah.
Huh?
There's more?
One more line. I gotta divide this over. Because you're solving for dy dx. So your final answer is 6x squared minus 6x squared y squared over 4x cubed. This one was more tedious, but you had to start off with the product rule, and if you didn't, I think I wrote chain rule. I got so depressed at some point, I mixed all my rules up. But please ask me a question if you have any. Or yeah, soak it in.
I got there. I just do stuff.
Yeah, you did. You did really well. The algebra.
Yeah. Everything else.
Okay, any questions?
Googled it.
It's like the model for what not to put.
Do what? Are you serious? Okay, I'll do it later. I don't have a phone with me. Remind me. So you acted out the little graph thingy? She was telling me about it. I was laughing so hard. I forgot my phone.
That's segregation. Integration, no, segregation. Okay, number something. 8. Okay, number 8. The next rule y'all hate after chain rule is U substitution. Oh my sweet Lord, help me. Some of y'all, yes, some of y'all did try U sub and then reinvented calculus.
I did.
Yeah, Mustafa, you did something. Okay, this is what you need to do to determine if you need U substitution. Quickly, what's the derivative of this?
The same as I think.
X to the 4th, right? Guess what I have? X to the 4th. This is a quick way of knowing if you need U substitution or not. Okay, so U sub, I'm only going to put the inside. I can handle that exponent, I just can't handle the inside. So this will be 3x to the 5th plus 1. So my derivatives, do we add 1 or subtract 1? Subtract. So that's going to be 15x to the 4th dx. Look at this right here. This is, mathematically speaking, this should make you happy. Because I can knock out 15x to the 4th in 1 slash.
Do it.
Okay? Peer pressure.
Do it.
Okay, so let's go back, and now we're going to actually make the substitution. I'm going to replace the inside with u, so it becomes u to the 1/2. I'm going to replace 15x to the 4th dx with what it equals, du. Some people pulled the u in and then had your 15x to the 4th here. If you have a u and you have an x at this stage, stop. You forgot to do something. Okay?
Repeat that.
If you have a u and an x right here,
Oh.
do not pass go. Do not collect $200. You forgot something.
Oh. Du is the derivative of u.
Yes.
Oh my god. Oh.
He is my blonde. Okay, one of my blondes. Okay, so far so.
Oh, it's okay, Mr. Vitrano. We have retake tomorrow.
Okay, I'm gonna go jump off a C building.
It's just bad.
Jump in the pool. Okay. Okay, so now, when we take the integral, add or subtract?
Yeah.
We add. So if I add 2/2 to this, I get 3/2, and then we multiply by the reciprocal. I love some of y'all. Y'all did something, got a crazy answer, but you remembered your plus C.
Yeah, I did.
I was like, okay, something's tough. Small steps. Then, now, what was my U? 3x. Now I want to replace U with what it originally equaled, plus 1, to the 3/2 plus C. Okay? Because remember, I can take an antiderivative of an exponent. It's the messy stuff that was inside that was keeping me down. Okay?
Is that it?
Yeah, that was it. That was one of the hard problems.
No, it wasn't. The next one. Yeah, the next one.
Next one, yeah, I realized something afterwards. It didn't matter for most of y'all after that. Okay.
I forgot my 3 of the box. That's not fair. Just continue.
Okay.
Oh.
I didn't even try.
Yeah.
I went down the steps, so I was like, I know you need U, and that U has to equal that, and that's it.
Any questions, comments, concerns?
Continue.
Okay, 9. I loved y'all so much, we did U sub all over again. Yes, is U substitution.
Wait, how though?
Patience, young grasshopper. Answers come to one who wait longer. Okay. Okay. This is where the time quizzes I was hoping to pay off.
I didn't.
Yes. Do I know? Side note. If I simplified it to that way, can you tell me the answer? Negative cosecant. Okay. If this doesn't have a negative here, it has to have a negative here, right? Right? Y'all can tell me that's right now, right?
Yes. Please.
Why is it different now?
Because there's no
Stop. Let's not focus on all the other stuff. I have this and I have this. I know
That's me.
I can deal with the cosecant cotangent, right? That's not making me sad. What's making me sad? That 3x cubed minus 5. So guess what? We're going to make that substitution. Yes. So we're going to let u equals 3x cubed minus 5.
This is packed.
It's amazing when you give people 4s. They show up. Don't cry in front of the class. You're kind of blocking. Okay, don't push me. Okay.
Wait, Eddie, what did you get?
You're great, everybody, you're great spirits. The good work.
Okay, come back to me. Guys, TikTok. Okay, so the thing that's...
You're still in the middle of everything, man.
It's recorded.
Okay, the thing that makes this whole thing ugly is that 3x to the third minus 5, right? If I quickly take the derivative of that, I get x squared, right? I got an x squared on the outside. We're going to be okay. This is, what's the derivative of this? 9x squared, right? Forget the 9. I have an x squared out here. This is where I don't know if I might have messed up. Okay, so, chill, bro. Okay, so du equals 9x squared dx. Okay? Not a big deal. Yes?
I thought the rule was that for you to use substitution, you have whatever you
Okay,
do.
okay. I realize some people actually work their way through it. Some, if they did everything right, but that one number I only took off a point. Because I got you. That's why I'm fixing this. Okay, so we have a problem that 18 and the 9 don't match, right?
Yeah.
But we got the x squared. So, okay, so let me do this. Let me rewrite this original to be, let's change colors. I'm going to change colors. Okay, so I'm going to put the 18 on the outside because I don't have anything to match up with that, right? So I get cosecant 3x to the third minus 5, cotangent 3x third minus 5, x squared dx, right? Yeah.
Why do you have to put the 18 out?
Because I can't handle the 18 because I don't have an 18 to replace it with. I need you to have patience. Chill. Raw.
Now why is it?
Chill. To make my substitution.
Okay.
Okay, so what I need to do is I'm going to divide both sides here by 9. So I get 1/9 du equals x squared dx. Okay.
Yeah.
I could have multiplied both sides by 2 as well. No, I couldn't have done that. Okay, so now I can make this substitution, right? Okay, so let's make it pretty. So it's 18 integral cosecant u cotangent u times 1/9 du. Talk to me. Come on, give me a question. I want a question from you. Question, statement, comment, and I will die or drop out of high school is unacceptable. Okay,
Yeah.
because you see I have this x squared dx, and notice I have that in here. I just don't have a 9. I needed an 18, and I have a 9. I don't have enough to make it work. Okay? So what I did was I divided both sides and said, well, you know what? It's a constant. 18 is a constant. Constants are illegal to go on that side. So I pulled my 18 out. And now I just have that 9, x squared dx. Well, I have that. I can handle constants all day long. I can't handle x squares. So I replaced x squared dx with 1/9 du. That's what I did right there. Huh? I divided. Remember I had this situation, du equals 9x squared dx, right? I divided both sides by 9. So that left me with 1/9 u equals x squared dx. Okay. I had to move the 9 over. Okay. Any questions so far? Okay, so I'm going to move that 1/9 over. So I get 18 over 9. Cosecant u, cotangent u, du. And there's our hidden little gem. What's wrong, Max? Oh, okay. Okay. 18 divided by 9? 2. The integral of cosecant cotangent. Negative cosecant. I just I moved it over, so 18 times 1/9 is 18 over 9. Cleaned up, and let's take out. We gotta take that u out. U was what again? Minus.
Yeah.
It looked uglier with that cosecant and cotangent, but it's kind of one of those I need you in that mindset of, oh my gosh, I know the antiderivative of cosecant cotangent. Yeah? Talk to me. I can't talk. I want ask me a question. Didn't sound good. Okay. Yes. Okay, questions? Guess what the next one's all about?
Same thing.
USUB, yes. God bless America, I had fun. How? Okay. 10. It works the exact same way, 40x cubed, secant squared, 5x to the 4th plus 1 dx. Yes.
Is it the same way we took the
I realize the number, but you still could have handled the cosecant cotangent. And most of people could not handle the cosecant cotangent.
So you
That's where we have fun.
You do the same thing with the constant?
We are going to do the same thing. Okay. Again, reinvention. At this point, it looks ugly, right? Let's stop and look at the bones of this. Can I do this? What's the antiderivative of cosecant squared?
Secant x.
Not derivative. Tangent. Right? The antiderivative of cosecant squared is tangent. Okay? So if I come back to this, which does look nasty, the bones of this is what's secant squared x? Right? So secant squares not make it ugly. We can handle that. What can't we handle? The inside. So we're going to make that our u. And if I take the derivative of that, I get an x cubed, which I have. And like I said, if you could handle everything but that 40, I was going to take care of it. And we're going to handle this in the exact same fashion. I have the x cubed, so what I'm going to do is I'm going to move the 20 over. And I get 1/20 du equals x cubed dx. Okay? So the problem we just handled is going to work. This is going to work the exact same. Okay? So I'm going to move the 40 on the outside. I'm just going to rewrite it so it's easier to see my substitution. It was 5x to the right? So if I rewrite it like that, it's easier to see where my du is going to go. I'm hoping, because my interpretation of what was going on, and it was the trig functions that were tripping you up. Yeah, definitely not a mentor. The trig function should have been the thing that should have made you feel a little homey in math-ish. You're good? Okay. And now I'm going to move the 1/20 on the outside. Talk to me. Okay, so I'm going to move the 1/20 on the outside. So it'll be 40 over 20. Right? Antiderivative of secant squared. Tangent. U plus C.
Shauna,
Yes, ma'am?
can you scroll up? How did how did that turn to 1 something?
It's the same thing.
Right here I made the substitution.
Oh yeah, okay.
Okay.
Oh.
Okay, and then that's 2 tangent 5x to the 4th plus 1
Correct.
plus C.
That's it.
That's it. The thing I think y'all got most freaked out about should have been the thing you hopefully next time feel more comfortable with. Okay. This is why those time quizzes and these note cards are important. You need to know those. When you see those in a weird way, bless you, you're going to say, oh my gosh, I know this. Okay? Any questions on those? Okay. Okie dokie. Then we have fun on the
No
back.
matter when you make it a tangent.
Okay, when I drop this is when I want to make a tangent. So when I see tangent, I should not see that with that. By dropping the integral sign, you have now declared that you've done it.
Okay, so you drop the integral when you do the little thing, right? When you make the fraction. Okay.
Now, could you have Ruth? We could have done this where you brought the 20 out and then kept it like this.
Yeah, that's what I did.
And then when you come there, that's fine. As soon as that secant square turns into tangent, that symbol has to go away. Kim, you're good? Okay. Number 11. This is not natural log. Okay, not a natural log problem. Because natural log would have been 1 over x, right? This is not 1 over x. I'm going to rewrite this in exponent form. Okay. And evaluate it. So it'll be -4. Am I going too fast?
No.
Okay. Integrals, add 1, subtract 1. Add. Add. So -3 plus 1 is -2 multiplied by the reciprocal. And evaluate it from 1 to 3. This cleans up to 2 over x squared from 1 to 3. God bless America. Y'all have fun. I got LNs of 100 and somethings.
Remember when I asked you that?
That was mine.
So 2 over 3 squared minus 2 over 1 squared. So 2/9 minus 2 over 1. Multiply by 9. Multiply by 9. Bless you. And you just get -16 over 9.
I thought they couldn't be negative.
Who said that? I get negative numbers are perfectly fine as long as they're not on my banking account, right? You can't have a negative under a square root either. Other than that, negatives are perfectly lovely. Right? Yeah. You made up your own rule. There we go. Yeah, negatives are the evil. Okay. Any questions on this one? Good? Okay. I promise you this question was not meant to tease. Make hard. You were taking the derivative.
I just saw a fraction, like maybe, but I want to attempt something. Like maybe.
Well, you did. You would have been right if you did the derivative. But it was the integral. I would rather you commit to something. It's kind of like wrestling. If I'm going to go, let's go all out. Win or lose. Kim, are you good? Okay.
That's it. How I got
You went with it. Y'all had fun. Okay, last but not least, number 12. Okay. You can handle this one in the same fashion. Okay. You can handle this one in the same fashion. If you do that, okay, we're almost done. Okay. You add 1 to the exponent, right? Well, what happens when I add 1 to the exponent?
It becomes
0.
Natural.
Can I get a 0? No. Okay. So let's do this.
Wait, what happened?
Okay.
I'm on a
If I add 1 to this, I get what? 0. Can I get a 0 as an exponent? No. Take another route. So let's do this. Let me pull this apart.
Okay, man.
If I write it like that, right? Because I got 0, that meant there's something I need to know. There should have been a formula, something. So if I rewrite it like this, do y'all see what the integral is looking at? And this one is natural log. So it's -3 natural log of x from 1 to 3.
Thank you for telling me.
You're welcome. So it's -3 natural log of 3 minus -3 natural log of 1. I'm going to let it go. It's okay. What's the natural log of 1 technically? 0. But even if you left it at -3 natural log 3 plus 3 natural log of 1, technically this goes to 0. Again, I told you you didn't have to clean it up, so you could have stopped here. And that was that problem. Please don't throw up on me.
Do we have to learn like natural laws?
No, you cannot. Okay. Hey, guys, you do not need to know your natural logs. If it was a multiple choice question, Marco, they would have given you this. Just know natural log of 1 and 0. You can take the test home.
Mr.
Thank you for coming.
I freaking had it, but I crossed it out.
How do you stop? How do you stop this?
I love you.